Good morning, students. Today we are going to start a new chapter, Current Electricity. It is very much similar to the electricity chapter of class 10th. So, first term is electric current. So, what is electric current? Whenever there are charged particles moving in a definite direction, it makes a current. Like in the previous lecture, we studied electrostatic. Static means at rest. When the charges were at rest, it is said to be electrostatic. But when charges are moving, it makes a current. So this chapter name is current electricity. Now, electric current. Electric current in solid is due to the valence electrons. Electric current in the semiconductors is due to the electrons, that is negative charge, as well as there are holes which is known as positive charge. You will be studying this in the unit 9 of class plus 2. Now next is liquids. In liquids, charge carriers are ions. Such liquids are known as electrolytes. For example, NaCl. Sodium is positive ion and chlorine is negative ion. So these are the charge carriers. Next is gases. In gases there is no charge carriers. So gases are basically insulators. But these can be ionized by applying a potential difference. It should be at a low pressure. Next is electromotive force, which is also denoted as EMF. Electro means charge, motive means motion, force means force. The source of external force. कहीं कोई भी हम एक्सटर्नल फोर्स बाहर से लगा रहे हैं ताकि जो चार्ज है वो हमारे एक पर्टिकुलर डायरेक्शन में मूव करें. जस्ट लाइक बैटरी, जब हम बैटरी को अप्लाई करते हैं तो चार्ज कैरियर्स एक डायरेक्शन में मूव करते हैं. दिस इज कॉल्ड इलेक्ट्रोमोटिव force. For example, it is provided by cell and battery. Now the EMF of cell. Electromotive force of cell. It is a maximum potential difference between two electrodes of the cell. As you know, in the chemistry also the cell is made up of electrodes, right? So the maximum potential difference between these two electrodes when it is in open circuit, it is called EMF of the cell. That means what capacity it is holding to move the charge carriers. Whenever there is potential difference between the electrodes, the current is flowing. When the potential difference is diminished, that means there is no more potential difference, then a cell is said to be dead. So EMF is denoted by a small e, just like permittivity, which you have studied in last chapter. So it is a line integral of E dot dl. Here E is field and dl is the small path which the electrons have covered. The SI unit of EMF is volt, or we can say joule per coulomb. EMF of cell is said to be 1 volt if 1 joule of energy is supplied by cell to drive 1 coulomb of charge around the whole circuit. It is said to be 1 volt. Now the factors which depending upon the EMF. EMF of the cell depends upon the nature of the electrode, obviously which type of electrodes you are using. Second is nature of the concentration, kitni unki concentration hai, right? And temperature. If the it also depends upon the temperature, whether the temperature is high or temperature is low. Now next is the electric current. What is the proper physical definition of the electric current? That is rate of flow of electric charge across the current. The how many charge is moving per unit time is known as current. So the SI unit of the current is ampere, because the SI unit of charge is coulomb and the time is second. So 1 ampere is said to be 1 coulomb upon second, coulomb per second. Also it is denoted as 1 joule upon 1 coulomb, right? It is mentioned wrong. 1 ampere is 1 coulomb upon 1 second, right? Next is the direction of current, because current is constituted of the moving of the electrons. So when the direction in which electrons are moving is said to be electronic direction of the current. फॉर एग्जाम्पल इलेक्ट्रॉन जो आपके मूव कर रहे हैं वो टुवर्ड्स द पॉजिटिव चार्ज मूव करेंगे, बट जो करंट है वो आपका पॉजिटिव टू नेगेटिव होता है. इट इज़ सेड टू बी कन्वेंशनल करंट, और वो जो हम कंसीडर कर रहे हैं डेट इज़ कन्वेंशनल करंट. डैट मीन्स जो हमारा कन्वेंशनल का मतलब है जो हर चीज़ हम लेते हैं, फॉर एग्जांपल वाटर है, वाटर जो है हाई लेवल से लोअर लेवल की तरफ ट्रांसफ़र करता है, सेम टेम्परेचर हायर टेम्परेचर टू लोअर टेम्परेचर बॉडी ट्रांसफ़र करता है। उसी हिसाब से अगर हम देखें तो जो चार्ज भी करंट भी है वो हायर पोटेंशियल से लोअर पोटेंशियल की तरफ जाना चाहिए। तो हायर पोटेंशियल इज़ पॉजिटिव, लोअर पोटेंशियल इज़ नेगेटिव। सो द कन्वेंशनल डायरेक्शन ऑफ द करंट इज़ from positive to negative, and we consider this conventional current direction, not the electronic direction, which is the direction of the moving of the electrons. Next is the current. Now current quantity, physical quantity. We have studied vector quantity and scalar quantity. Scalar quantity, we remember, is the quantity having only magnitude, and the vector quantity is the quantity having magnitude as well as direction. Now you will be surprised to know that current is a scalar quantity. Yes, it has direction. We consider the direction of the current, but still it is a scalar quantity, because when we edit the currents, the direction is not considered, the angle between the current branches is not considered. So the addition of the current is always a scalar, so we consider the current is a scalar quantity. Now see the example. I0 is the current going to the junction, I1 is the current moving out from the junction, and I2 is also the current moving out of the junction. Now we simply add I1 plus I2 two current values. Not we are considering the angle between these I1 and I2. That means we consider only the scalar additions, not the vector additions. Now the next is the electric current in conductors. The first is when no field is applied. So since when we have not applied any field, there are free electrons having some energy, so there is a random motion. So the first point is when no field, free electrons have the random motion. So they collide with the fixed ions in the material. जो मटीरियल में फिक्स्ड आयंस हैं ऑलरेडी, उनके साथ कोलिजन्स होती है, उस कोलिजन्स के बाद उनकी पूरी एनर्जी ड्रॉप हो जाती है, देन अगेन दे रीगेन द एनर्जी, बट नेक्स्ट टाइम जब वो दोबारा अपनी जर्नी स्टार्ट करते हैं द डायरेक्शन इज चेंज्ड. सो डैट मीन्स अगर वो राइट साइड को थोड़ा सा पॉजिटिव, राइट साइड को वो 5 मीटर गए हैं तो लेफ्ट साइड पे वो 4 मीटर चलेगी, तो नेट डिस्प्लेसमेंट इज 0. डैट मीन्स देयर इज नो करंट इन द सर्किट. Hence, average thermal random velocity of the electrons is 0. That result, there is no current, right? That it is denoted by the mu. The thermal energy is denoted by the mu. So, if mu1, mu2, mu3 up to mu n are the random thermal velocities of n free electrons, then the average thermal velocity of n electrons is said to be 0, and thermal velocity of electrons are of the order 10 raised to power 5 meter per second. Now what if when we apply the field? Now when we apply the field, as we know that when we apply the field, the positive charge are aligned along the direction of the field, and negative charge in the direction opposite to the field. Now free electrons experience force because field is applied, there is a force. So in this force, electrons are accelerated from negative to positive ends, right? The electrons are moving to the positive ends, and on their way accelerated free electrons collide with the ions. अब collision तो इनके साथ भी होगी, जो collision थर्मल के केस में हो रही थी, तो collision होगी तो that means ये kinetic energy लॉस करेंगे. अब kinetic energy लॉस करके वो दोबारा, क्योंकि फील्ड बाहर से मिल रही है, दोबारा एक्सेलरेट होंगे. ऐसा नहीं है कि वो रुक जाएंगे, अब फिर वो दोबारा एक्सेलरेट होंगे, लेकिन डिफरेंस क्या आएगा, अब वो फिर वो उसी डायरेक्शन में जाएंगे जिस डायरेक्शन में वो जा रहे थे, बिकॉज देयर इज़ अ फील्ड. तो फील्ड के कारण वो दोबारा उसी डायरेक्शन में जाएंगे. तो डैट मीन्स अगर एक इलेक्ट्रॉन ने यहाँ से जर्नी स्टार्ट की, कोलिजन होगी, उसकी वेलोसिटी डाउन होगी, फिर वो डायरेक्टेड हो जाएगा दोबारा पॉजिटिव साइड की तरफ, देन अगेन कोलिजन, देन एनर्जी ड्रॉप, रीगेन द एनर्जी, एक्सेलेटेड, देन मूविंग. तो ऐसे ऐसे वो जिगजैग मोशन में मूव करता हुआ तब तक वो उसकी मूव करता रहेगा जब तक वो पॉजिटिव एंड पे नहीं पहुंचेगा. डैट मीन्स प्रोसेस कॉन्टिन्यूज टिल इलेक्ट्रॉन्स रीच द पॉजिटिव एंड. So each free electron described curved path between collisions and average velocity is not 0. जैसे कि हमारी जो पहले थी जो थर्मल एनर्जी that was 0, बट यहाँ पे एवरेज वेलोसिटी हमारी 0 नहीं है. So this velocity is known as drift velocity. The drift velocity is the average velocity with which free electrons get drifted. Drifted means भाग रहे हैं वो towards positive end under the influence of फील्ड। तो जो ड्रिफ्ट वेलोसिटी की वैल्यू होती है वो 10⁻⁻⁴ मीटर पर सेकेंड। ये थर्मल वेलोसिटी से बहुत ज़्यादा कम होती है। नाउ एक क्वेश्चन माइंड में ये भी आता है कि अगर ड्रिफ्ट वेलोसिटी की वैल्यू इतनी कम है 10⁻⁻⁴ मीटर पर सेकेंड, तो जब हम बल्ब स्विच को ऑन करते हैं तो बल्ब उसी टाइम ग्लो कैसे कर जाता है? तो ऐसा नहीं है कि हमारा इलेक्ट्रॉन यहीं से जर्नी स्टार्ट करेगा, हो सकता है कुछ इलेक्ट्रॉन यहाँ, कोई इलेक्ट्रॉन यहाँ पे भी हो, तो उसके लिए पाथ कम है। तो एवरी इलेक्ट्रॉन विल बी अलाइंड इन दिस डायरेक्शन। तो वो धीरे धीरे उसकी जो ब्राइटनेस है इंक्रीज होती होती जब तक सारे इलेक्ट्रॉन यहाँ पे पहुँचते हैं तो बल्ब पूरा ब्राइट होके ग्लो करता है। नाउ कंसीडर अ कंडक्टर हैविंग लेंथ ऑफ L, potential difference across the end is V and field applied is E, capital E. So E is equal to V upon L. As we know earlier, we also used this expression in the last chapter. Now charge on electron is E. So force experienced by electron is F is equal to QE. Formula we remember, F is equal to QE. So here Q is minus E. So F is equal to minus E into E. Also force is equal to mass into acceleration. So when we equate these two equations, so the value of A is minus E upon m. That is, the acceleration provided by field to the electrons is minus E into field upon mass. Acceleration of the electron is proportional to the field. जितनी ज़्यादा field होगी उतनी ज़्यादा वो accelerated होंगे. Positive ions are heavy. हमने यहाँ पे इलेक्ट्रॉन्स की बात की है, पॉजिटिव चार्ज की बात नहीं की, बिकॉज पॉजिटिव चार्ज है उसका जो वेट है वो हैवी ज़्यादा है, तो वो इसलिए वो ज़्यादा बाउंड है मेटल के साथ, तो वो मूव नहीं करे, सिर्फ इलेक्ट्रॉन्स ही मूव करते हैं. नेक्स्ट वी विल बी स्टडिंग रिलेशन ऑफ ड्रिफ्ट वेलोसिटी इन द वीडियो.